I welcome you back. I welcome you back to my YouTube channel, Mwalimu Education Services. We are going to start we are going to continue from where we stopped. Allow me share my screen. Hope everything is going on smoothly. I assume that all your endeavors are going on smoothly. And soon the term is resuming. I think this is going to be the last video I'm uploading on nuclear processes, as of this holiday. This is going to be the last video, but I will continue uploading. But as far as nuclear processes is concerned, regarding the holiday work which I gave, this should be the last video. So we had stopped on properties of radiations that are emitted during the decay process. Today we are going to continue with something else. We are going to look at effect of radiations on atomic number and atomic mass. Hope my screen is now clear. Effect of emission of radiations on atomic number and atomic mass. So when a radioactive substance undergoes decay process, let me show you an example here. If you recall from our previous session, where is this thing? Stop sharing the share. A moment. Let me share this. So when a radioactive substance undergoes decay process, it emits radioactive particles. For example, here we have, hope you are seeing my cursor. This, I'm going to tell you how you will present this, but let me first explain. But you'll have to put it somewhere. I'll tell you at the end. So we have this unstable atom, which is heavy. This one you are seeing. So it undergoes disintegration. It breaks down. It undergoes radioactive decay, so that it forms a stable atom. And once it undergoes decay process, there are these particles that are emitted. Now these are alpha particles. We also have another example here where you are seeing beta decay. We have nuclei of unstable atom. Nucleus of unstable atom, it undergoes radioactive decay so that it forms a stable atom by emitting a beta particle. So that's what we saw last time, that these heavy unstable atoms undergo disintegration. They disintegrate to form things that are stable. So once they disintegrate, once these things that are unstable disintegrate and form stable things by emitting particles, something changes. To their atomic number and atomic mass, as we are going to see in this session. Allow me now introduce today's session. Let me introduce it formally. So today, basically, we are going to look at effect of emission of radiations on atomic number and atomic mass. So we start with the emission of alpha particle. The question is, once the nucleus of heavy unstable atom, if a heavy unstable atom undergoes decay process and undergoes decay process by emitting an alpha particle, what will happen to its atomic number and atomic mass? Hope you've got the idea, the key issue which we are investigating here. I have said what we are going to look at in today's session is that given an atom of an element, if it undergoes decay process, if it breaks down to form an atom to form a stable atom, if it breaks down to form a stable atom by emitting an alpha particle, what will happen to it? What will happen to it if it emits a beta particle? If it emits a gamma particle, what will happen to it in terms of atomic number and atomic mass? That's what we are investigating today. So we start with the emission of alpha particle. And here we are saying that this reduces atomic number by 2 units and atomic mass by 4 units. So this is the effect of alpha particle. How are we going to understand this? So what I am meaning, I am giving here an example. In particular, we consider the decay process of boron. So the example I've taken is that of boron, the atom of boron. So boron is undergoing decay process by emission of alpha particle. I give you an example here. So this is boron. It has atomic number 5 and atomic mass 10. It breaks down to form this particle. If you recall in our previous table, the first row where we had in nature, we saw that alpha particle is a particle that takes on this form. This is how we describe the alpha particle. It is an atom of helium, nucleus of helium. So here we have boron breaking down by emitting this particle plus something else which I don't know. So it emits this particle and it also changes to form a stable atom. So we want to investigate what is this stable atom formed. So to investigate what this stable atom is, we are going to do some mathematics. So this is a chemical equation. You treat this arrow, look at this arrow as you can look at it as an equal sign. So we have, considering the values that are up, we have 10. Values that are up, 10 is equal to, where you are seeing an arrow, we have equality. 10 is equal to 4 plus A. We have 10 is equal to 4 plus A. These are the things that are up. And simplifying this, collecting like terms to get the value of A, if I bring 4 this side, if 4 comes this side, we shall have A equals 10 minus 4, and we obtain 6. Similarly, we do the same thing down. We have 5 equals, treat the arrow as, look at it as an equal sign. 5 is equal to 2 plus B. So down you have 5 equals 2 plus B. And making B the subject, taking to this side, we shall have B equals 5 minus 2. And this gives us 3. Therefore, this Y you are seeing here, Y will be equal to up where I'm having A is 6, and down where I'm having B, we have 3. So what has happened? Boron has undergone decay process. Boron has decayed by emitting an alpha particle and forming nucleus of this element you are seeing here. As in, we have converted it into another atom. So once something decays, it can change. Here we have seen that it can change. If it decays by giving out an alpha particle, it has changed into this. So in this case, in summary, in this case, atomic number of boron, remember atomic number of boron was 5. Atomic number of boron was 5, has reduced by 2. It has reduced by 2. We have subtracted off 2 to obtain this 3 you are seeing here down. And atomic mass has reduced by 4. Atomic mass has reduced by 4. The mass was 10. Now we are having 6. We have taken off also that we obtain this. So in summary, the decay process that involves emission of alpha particle reduces atomic number by 2 and reduces atomic mass by 4. Let me give you another example here. You are going to note down this example. This is the example. So in this example, the heading is, you put the heading after noting down the things I have been explaining. The heading of this sample material is emission. The heading is emission of alpha particle by radium. Emission of alpha particle by radium. Radium, the spelling is R-A-D-I-U-M. So here I give you another example of another atom. In the first example, recall that we have been looking at boron. So radium is an element with this symbolic representation. So it breaks down, it undergoes decay and emits an alpha particle. This is what we call an alpha particle. It has this symbolic representation, if you recall from our previous table. So what is taking place here is that the atomic mass is what is up. This 226 has reduced by 4. How? You are seeing 226 minus 4 to obtain 222. And atomic number 88 has reduced by 2. How? 88 minus 2 we obtain 86. So this is the new element which is formed. This is a new element which is formed when the alpha particle has been emitted. So you are going to draw this and please shade it. You are seeing these colors. For me, I don't know these colors. The girls are the ones who know them. You will ask your colleagues which colors are these, but you shade them so that it looks attractive. So that is the case of emission of an alpha particle. It reduces atomic number by 2 and atomic mass by 4. Hope you've understood this very well. Because in the next case where we are going to look at emission of beta particle, I am going to leave an activity. The key idea is that once you have an atom, if it breaks down by giving out this, if it breaks down by giving out an alpha particle, to obtain the new, listen, once you have an atom, once you have an atom of a radioactive element, if it breaks down by giving out an alpha particle, to obtain the new element which is formed, for example, here the new element which is formed is called randon. This is radium decaying to give us randon. So to obtain how this element will look like, you get the atomic mass of the first element, which was radium here, and you subtract off, you remove 4. That is the atomic mass. You remove 4 so that you obtain the new atomic mass. Then for the atomic number, you remove 2 so that you get the new atomic number. Like we have seen in this first example. Like we have seen in this first example of boron. Like we have seen here in the first example of boron, the atomic mass initially was 10. So we had 10 minus 4 to obtain 6. That's what we done. That's what we have done. Then down where we have atomic number 5 minus 2 to obtain 3. This 4 and 2, they are coming from the alpha particle, since the element has given out the alpha particle. Yeah. Now we look at something else. Emission of beta particle. Now, emission of beta particle, this increases atomic number by 1 unit and atomic mass remains constant. Why do we say that it increases atomic number by 1 unit and atomic mass remains constant? We consider the same example. So in this case, I'm giving you an example, but considering the decay process of boron, in the first case, we have seen the decay process of boron by emission of alpha particle. This is decay process of boron by emission of beta particle. So we have our boron breaking down to emit. This is what we call the beta particle. If you recall from our previous table, we saw that the beta particle has this symbolic representation. So it is giving out this plus a new atom, which I don't know. So we now look at establishing what this new atom is. So up here we have 10. 10 will be equal to 0 plus A. For digits that are up, we have 10 equals 0 plus A. And making A the subject, we shall have A equals 10 minus 0. And 10 minus 0 is 10. Then down we have 5 equals negative 1 plus B. That's what is down. 5 equals negative 1 plus B. And making B the subject, bringing negative 1 this side, we shall have B equals 5 plus 1, and this gives it 6. So substituting back the values of A and B, our Y is equal to 10. So this is what we mean by atomic mass remains constant. Atomic mass does not change if an atom emits or releases a beta particle. Its atomic mass does not change. Due to this calculation here, which we have seen, the calculation of 10 equals 0 plus A has remained as 10. The way it was originally in boron, it is still the same way it is in Y. It is still 10, it has not changed. However, for atomic number, we have seen here that it has now become 6. Originally, it was 5. Now down you have 6. Because the value of B we have obtained is 6. So in this case, what has happened? Atomic number of boron has increased by 1, and atomic mass has remained constant. So once an atom undergoes the decay process by releasing a beta particle, its mass, the atomic mass, does not change. The atomic mass does not change. However, the atomic number which is down increases by 1. So which activity am I going to leave here? So the activity which I'm going to leave here, you are going to consider here. I have consider the decay process of boron by emission of beta particle. That's what I have considered. So here for you, you are going in the activity, you are going to consider the decay process of this thing here. Now this is what we saw for alpha particle. You are going to consider the decay process. So you write activity. Then in that activity, you say consider the decay process of radium. So you redraw these things. You are going to redraw these things, but when we have beta particle here, these drawings will remain. You leave them the way they are, shade them, but this also will remain the same. You are considering radium. I just want you to find what will be here. Are you seeing? Here where we have 222, 86. We obtain these things in alpha case, in emission of alpha particle. So for me, I want you to find what will be here. If here I'm having the beta particle. Establish what will be here. Find what will be here. If here I am having a beta particle. Hope you've obtained, you've understood what the activity requires you to do. These are the things that we did for alpha. So you are going to draw the same diagram, shade them. Then here down, where we have radium is going to remain the same. I just want you to show what will be here. If that radium undergoes decay by emitting alpha particle, so find what this will change. You can call it like Y or capital A. Like in my example, I've been calling it capital Y. You will call it capital Y or capital A, anything. Then up here, you find what will be up, which value, and also which value will be down, given that this radium undergoes decay by emitting beta. Yes, by emitting beta particle. Let me hope that is clear. Now we look at another type of emission. For another type of emission, remember they were three particles which we looked at. Why is this thing failing to move? I don't know why it is failing to move. Oh, it has moved. So emission of gamma particle. For emission of gamma particle, what are we saying here? This does not change both atomic number and atomic mass. It does not change both atomic number and atomic mass. Still, I consider the decay process of boron by emission of gamma particle. This is our boron. So we want to see what happens to this boron if it emits gamma particle. From our previous table, we saw that gamma particle has this symbolic representation. It has this symbolic representation. So we want to know if it emits, if our boron breaks down by emitting this particle of gamma, what will happen to it? Now, up we shall be having 10 equals 0 plus A up. I told you treat this arrow as an equal sign, and making A the subject, you have 10 minus 0, implying that A will be 10. Then down you have 5. 5 equals 0 plus B. 5 equals 0 plus B, and making B the subject, B equals 5 minus 0, I think. This is not a plus. But 5 minus 0 is still 5 here. Obtain 5. So substituting back the values of A and B, so we obtain A equals 10 and B equals 5. You are seeing here that nothing has changed. Nothing has changed due to the nature of the gamma particle that has been emitted. The mass has remained the same. The mass has remained the same. The atomic number has also remained the same. So in this case, the atomic number and atomic mass of boron have remained constant. So if a radioactive element emits a gamma particle, its atomic number and atomic mass, do not change. Do not change. Therefore, I give you another activity here. Another activity. Still considering our radium. So in this activity, the heading is, as in you put activity, heading is activity, then you consider the decay process of radium. So decay process of radium by emission of gamma, what do I want you to do in this activity? What I want you to establish what will be here, what will be formed here, given that this particle is of gamma, this particle is of gamma, not what? Not alpha. Just like you've done in the previous activity that has beta. So if this is gamma, what will be here? That's what I want you to establish. In conclusion, let me leave you with this table. In conclusion, after you've done the activity, this is our table. The table is navigating. Hope there it is visible. So what do I want you to note? So after capturing all those things, you are going to draw this table. So the heading of this table is summary of decay processes. Understood? The heading of this table is summary of decay processes. You have type, nuclear equation, representation, change in mass or atomic numbers. Change in mass or atomic numbers. So the first decay process is alpha decay. Alpha decay, these are the things that we have covered. Alpha decay, given an element that has this form. For alpha decay, we have seen that this A you are seeing up, the A reduces by 4, and this Z you are seeing down reduces by 2. That's what we saw in the first case. So and it is being captured here. So this is a summary that is going to help you understand those things. So A decreases by 4, Z decrease by 2. You also draw this. Draw this. So this arrow going down, it is showing an alpha particle that is released. The arrow that you are seeing here going down, alpha particle released. Then for beta, we have seen that A remains A and Z increases by 1. So A does not change, Z increases by 1. So this arrow you are seeing down, it shows that beta is being given out. Is being given out. Also here for gamma decay, it shows that gamma is being given out. Yeah, like that. So we shall stop here. I think now you have a total of 5 videos. Feel free to ask me anything that you have not understood, anything that you've not grasped very well. If there is anything that is confusing, feel free to inquire within the chat. I don't know whether some of you just come here, watch videos. After watching videos, then you go and do other things. That YouTube you are seeing, it has a section of chat. You can put your question there. I'll be able to answer the question in the chat. Yeah, it has. And you can subscribe, by the way. You can subscribe, but if you don't want to subscribe, still I will not force you to subscribe. But for me, what I want is for you to go through these things. Where you see any confusion, you will ask. Maybe as of now, you may not ask, but at school, hopefully we shall interact more. So allow me stop here. Stop here. Yeah.